Essentially, we've been building the fundamental blocks so far, and we'll soon finish that and we'll go to more interesting tasks. So for today, one of the remaining fundamental tasks is, lists that we already briefly covered in previous lectures, but we'll see it better now. And tuples and dictionaries. We'll see what that means. Next week will be classes, and the week after that, we will deal with how Python connects with neuroscience, like maybe some measurements that we can affect from Python, some brain-computer interfaces we can use with Python, or just other interesting use cases like that. Right. So for today, let's cover lists, tuples, and dictionaries. So do you remember lists from our previous lectures? Let me see if I can find it here. So these were the lists from our previous lectures. And basically, we know that we have generally integers, floats, strings, booleans, and those are our data types. But a list is something that has multiple of these. So basically, just multiple items together. And we write it with these square brackets, we separate them by a comma, and then we just write the content. Like this is a list of numbers, this is a list of text, and so on. There's a lot of operations we can do on lists, and let's have a look at some of the examples and we will understand better, like why we have them and such. Right, let's just go through lists. Let's start with the same basic idea as we had before, just as a reminder. Let's say we have some senses, right? So we have sight, we have hearing, we have smell, we have taste, and we have touch. Let's say, this is a simplification because technically pain is a sense, balance is a sense of temperature is a sense, but let's just go with the basics. And what this listing allows us to do is we can think about how many senses there are. We can think about what's the first sense, what's the second, what's the third. This is arbitrary right now, but generally. And we can also add to it if we later discover that actually it's more logical if we also include a sense of balance, for example. We can do it like this. We can say senses.append balance. And what this will do is basically no senses will include that as well. In fact, let's see it. We can print the senses here, and we can print the senses here to see the difference. And yes, by the way, we can print the lists directly. So when I click on the run, you can see here, first it was sight, hearing, smell, taste, touch. And then second time after we appended the balance, it got added to the end. So this is one basic operation that lists allow, which is that, basically we can add or remove elements. Could also say, can maybe remove a sense of smell because maybe I got COVID. This is a real story, sadly. And after that, we would see that, yeah. You can see here the sense of smell has been erased. By the way, is this visible? This part, is it visible clearly? Can you hear my voice? Okay. Yeah. All right. So basically, some of the main operations that lists allow us is we can print a list entirely. We can add an element, remove an element. Now, what else can we do? We can also say how many senses we have. So let's say print, and you'll remember this syntax. It's I have some value, in this case, len senses. And what this does is len, which is short term for length, basically gives us how many elements are in this list. So basically, in this case, we will get how many senses I have. Like, you've probably for sure heard about the 5 senses, which is an oversimplification. You might say that we have way more because of balance, temperature, whatever, but yeah, for now, let's just say I have 5 senses. get length of list with all x. So another thing that the list allows us is that we can access specific elements. Like, suppose I want to know the first sense. And by the way, I remind you, the list has indexes for accessing elements, and it starts counting from 0. So this is the 0th element. This is 1, 2, 3, and 4. So because it has 5 elements, the last element is going to be 4, and the first element is going to be 0. So as we can see here, the 0th sense is sight. For example, the 4 is going to be touch. Oh, sorry, balance, because we added balance, right? But yeah, basically, this allows us to access a specific element. And I will copy this entire Python file at the end of our lecture into the Discord so that you can look through it again, and we'll have some tasks to do with lists. But yeah, so far, what do we have? We have lists that are like square brackets. It can be a list of text or it can be a list of numbers, like we can say ages of students, and it can be like, yeah, just numbers, whatever. It can also be, of course, like 2, 3, I don't know, 2, 26, 10, 12, 18, 17, again 17, again 17. So yeah, the elements of the list don't have to be unique. They can repeat as many times as you want. It doesn't matter. All right, comment this out. Elements can have in type. Now, one thing that's very useful about lists is that we can use a for loop to go through them directly. And here's what I mean. Like, suppose I want to list out every one of my senses along with like the indexes that they have. Uh, One way I might do that with a while loop would be to get the index, which is at first 0. And as long as the index is less than the length of our senses, because we know that it starts at 0 and ends at 4, so as long as it's less than 5, what we would say is we would print the sense at that index. And in fact, we would say sense at index next is, and then like this. So these brackets allow us to directly inject variables in here. And we had to write f at the start of the string, then open the string. And yeah, just like that, we can insert variables here. And then we would increase the index by 1. Now let's see what that would give us. That would give us that sense at index 0 is sight, 1 is hearing, 2 is taste, 3 is touch, 4 is balance, and so on. Now, this way of writing is a little messy because you have to create this variable and check that it's less than length and increase it by 1. So a much shorter way to write the same thing, exactly same thing, is to say for index, not sorry. Yeah, for index in range of lengths of senses. Now let's see what this means. What this means is we still get the index variable, but it goes through every value in this range. What's range? If you remember from the last lecture, here's what range means. Let's just say, in fact, let's comment this out for now. And let's just say for x in range 10, print x, just to see what range does. So here's what it does. From 0 all the way to 9, it just printed out all the numbers. So if we had range 4, it would say from 0 all the way to 3, and so on. So effectively, range creates a list of numbers from 0 to whatever we write here, -1. And then we can go through them and assign each one to x. In fact, let's put a breakpoint in here so that it's clear what we're doing. So you can see here, x is first is 0. Then next time we come in here, x is 1, then x is 2, then x is 3. And then next time, we can see here that this is not going to happen again, and we exit. So this is what range allows us to do. And instead of writing 4 here, what we're writing is whatever the lengths of these senses are, which is in this case, we know it's 5. So we could just say 5. But let's say lengths of senses so that we can always adapt to it, regardless of if we add an element or remove it or whatever. Now we can say this is the index, to be clear. and we can print the sense at this index. And this will give us all of our senses. But another useful thing that we could do, instead of printing the indexes, we could go through the senses directly. So what we could do is we could say for sense in senses, print sense. And this way, we would also write out our senses, but this is way shorter code, right? Because directly we say for element in list. And yeah, this can be called anything, by the way, it doesn't have to be called sense, but I'm just calling sense because it's more obvious that way. So yeah, basically lists allow us to go through elements like this. So this is a list, and that's why we can do this. We can say for sense in senses, and then treat this as a variable one at a time. So let's go through it with a debugger to see what that means. You can see here the senses, right here visible as well, is a list with these values. Sense at first is equal to sight, then it's equal to hearing, then to taste, then to touch, and then to balance. And after that it exits. So that's what this allows us to do. And this is a very important operation that happens all the time in Python in real life. So we'll have some homeworks about this just to make sure that you develop an intuition for it. All right, let me see if we covered all the main parts. I mean, lists have some more features as well, but it's not really necessary to know everything by heart. What matters is that you know the basics and you know how to look up the rest. So in the past, you would go to the internet and you would go to Stack Overflow for looking things up, but nowadays, I actually unironically recommend either ChatGPT or Gemini. It's completely fine. And what I mean by that is that you can just ask it, like, let's just say, what is a way, no, let's just say, what is some strange thing a list can do in Python? Give example. And yeah, it could show you some weird things. So you don't really need to understand this right now. Just don't worry about this. I'm just using it as an example that I actually, I don't seriously do recommend to use some kind of AI tools for studying. But make sure that you don't use it to write your homeworks for you, because that way you don't really learn anything. Instead, use it to challenge you. So what I mean by challenge you is, for example, here's one example that I mean. Let's go to Gemini. And let's say I ask it to be my Socratic tutor and force me to explain to you how some things work for lists in Python. And what this allows you to do is basically it forces you into a conversation with Gemini or ChatGPT or whoever, doesn't really matter who. And it comes up with questions for you, and you have to speak and explain it to them. And then they push back on you, they say, no, not quite, maybe adjust this, and so on. Like in this case, it starts with what is a Python list and what is its fundamental purpose? And let's just say it holds multiple values. And this allows you to build up a conversation where you will for sure identify some knowledge gaps. I would identify some knowledge gaps as well because it's not really realistic to know everything. But what matters is that you are able to learn when the situation requires it. And so in this case, it's going to start some questions with me. I don't really care about that, but I just want you to be able to learn new things. And yeah, I will send some instructions about that as well, how I recommend to learn. But yeah, generally, don't use AI for writing homeworks, but do use AI for testing yourself like that, for sure. All right. So just one more thing that I will explain about lists is this. We can create sublists from lists. So here's what I mean. So for example, in senses here, we can see that smell and taste are chemical senses, right? So let's say I want to extract them. So chemical senses are smell and taste, but I don't want to write it like this. Let's say instead I want to just take this segment from the list. So we know it says indexes 2 and 3. So what I could do is we could say chemical senses are senses from 2 to 4. So this is where to start and where to end. And now if we say chemical senses, we can see here, actually, yeah. We can see here that we only got, oh yeah, yeah. Let's just not do any removals and additions right now. Yeah, you can see here we have 5 senses, and from 2 to 4 indexes we have smell and we have taste. This allows us to basically take a sublist from a list, from a starting point to an ending point. And this is a very useful tool and very necessary. And I will also give some homeworks about that. All right. Right now, is everything we covered clear so far, or would you like more examples of something here? Of course, I will periodically check the chat as well. Okay, if anyone has any questions, feel free to write it in the chat or to tell me. And don't worry if you don't instantly, intuitively understand everything, because half the job of a homework is to make sure that you actually understand what you heard at the lecture. So think of it as right now you're getting a general picture and you'll get an actual deep understanding from writing a homework. So yeah, no worries. Okay, so here's what we covered. This is how we create a list, or alternatively, we could make it with numbers or even like this. Some statements, and we could say it's like true, true, false, false, true. And by the way, also, we could also do it like this. Like lists don't have to be holding elements of the same type. Like in this case, this is a list that holds a lot of different types of elements, and this is fine. In most real cases, the list will hold elements of only one type, like only strings here and numbers here, but we are allowed to do this as well. And this is important because in other languages, like in Java, C#, C++, or almost any other language, this would not be allowed because lists would have to be of a specific type. But in Python, nobody cares. It's dynamic programming. You can have this kind of list if you want. Although this is not going to be practical because the entire point of a list is generally that you should be able to iterate through them and you should be able to do some operations on each element. And so elements should be of the same type if you're going to do the same operation on it. So generally, yeah, more realistically, you would always have lists of same type. Can have many types, but generally doesn't. Now let's see what else we have here. We have a way to add to the list. We have a way to remove from the list. We have a way to extract a sublist. Yeah, it's pretty much everything. We have a way to iterate from. These are the main things that a list can do. There are other things as well. For example, we can add two lists together. Let's see what that means. Like suppose we have chemical senses are smell and taste. And let's just say supernatural senses are, I don't know, intuition, telepathy, and clairvoyance. I'm just making it up right now. All senses can be just chemical senses plus supernatural senses. And in this case, this plus just means that a new list is created that has all these elements and all these elements. So now if I write all senses, you can see here we get smell, taste, intuition, telepathy, clairvoyance. So yeah, we can add lists. These are all the main elements of a list. There's also a way to insert elements at a specific index, but that's all, and to remove an element from a specific index and so on, but let's not worry about such details right now. These are all the things that you will need for most of the use cases, so we'll just focus on making sure that we intuitively understand each of these, and yeah, basically we'll just have some homeworks around this. Now, that's basically all that we need to cover about lists for today. So I guess I'll move on to tuples now. And by the way, when the meeting expires, we will join again from this link and continue. It's just fine. So tuples are basically same as lists, except that they don't change after being created. So like lists that don't change. This is known as immutable. So mutable is something that can mutate or change, and immutable is something that doesn't change. So here's what I mean. For example, we could say that human senses don't really change. It doesn't really make sense to add or remove. So you'd say that we define them once and that's it. Unlike lists, we can't really add elements or remove elements or anything, but everything else that we could do in lists, we can do here. So for example, we can go through them like this, just like we could with a normal list, as you can see here. We can also ask for a length, just like we could for a normal list. See here, it's 5. We can also take a specific element, so like human senses of 3, for example. You can see it's taste right here. And so basically any operation we could do on a list that did not change the list, we can also do on a tuple. But the operations that changed the list, like adding an element or removing an element, we can't do those things on a tuple. So as we said, lists can change and tuples cannot change. That's the only difference between them. So any so-called read-only operations are where change doesn't happen. So tuples and lists both have same read-only operations. Lists also have some write operations. Write operation is where some change happens. So this is important terminology. Read operations are when you only read the data and maybe put it in a variable or write it to the screen. And write operations are when you actually change the values. So in lists, we can write, meaning that we could change the element at a specific place or delete or add an element. But in a tuple, we only get to read it, nothing else. And lists are square brackets, tuples are braces. That's it. That's the only difference. Now, moving on to dictionaries. A dictionary is slightly different because it's a key-value pair. And let's see what that means. For example, let's say we have 5 students, and each of these 5 students have their own, let's say, grades. What we could do is we could say student grades equals, and we could create a dictionary. And here's what the dictionary looks like. So it's created with these brackets. You can see the curly brackets are these ones. These are square brackets and these are just braces. And inside here, we would give a key and then some values. A key is always a string and a value can be anything. In this case, let's say we have 5 students. I think, yeah, let's just go with these names. What does it matter? Let's say Alice has a grade of 90. Bob has a grade of 89. Charlie has a whatever, David and Eva has a grade of 99, let's say. In this case, this is a dictionary where keys are strings and values are integers. Now, keys have to be strings, but values can be anything. Like instead of 90, here we could have whatever. Or we could even have a list of values. So, or sometimes in a more complicated case, the value itself might be a dictionary of some kind. Like maybe in this case for Eva, we store different grades of different subjects. So I know this might be a bit confusing at first, but we'll go through this step by step. So first of all, the most important thing to consider is that just like lists, these hold a list of keys, which is these things, and each key is associated with a value. So the keys for key of Alice, the value is just a string, whatever. For Bob, the value is 85. For Charlie, the value is this list. For David, it's 88. And for Eva, it's another dictionary, which has these things. And yeah, by the way, we could also have another dictionary as a value in here, and so on. There is no limit to how far we could go. Let's just reverse that. This is called nesting, and this is important for JSON, but that's not relevant to us yet. It might be relevant in week 6, and so we might cover it, but for now that doesn't matter. What matters is that dictionaries allow us to form some kinds of connections between data. And now let's see how we would actually use a dictionary. So let's just turn this back into a realistic case. And realistically, always for the same keys, you'd have in one dictionary would have same type of values. That's what I mean. So let's just bring this all back to numbers. And so in this case, we have 5 students and a grade for each student. So what we could do is we could say for student in student grades. And by the way, one thing you can notice here is that when we iterate over a list, where did we have that? Yeah, like here. Each element is just an element of a list. Same with a tuple. But for a dictionary, when we iterate over a dictionary, the element here is just the key, not the whole thing. So in this case, if I print student, you can see only the student names got printed, like Alice, Bob, Charlie, David, Eva. We did not see their grades. But the way that we could see their grades is we could say grade equals student grades at student. So if you remember in a list, we could get an item at a specific index by giving the number for that index. But for a dictionary, we can get an item at a specific index by giving the string value of that index. So in this case, the value is whatever is in the student, which is at first Alice, then Bob, then Charlie, and so on. In fact, let's go through this, and we can print here. Student has a grade of grade. Let's see how this would work. Let's ignore that. So we arrive here. The student grades is a dictionary that we can take a look at over here. And we see that it's Alice 80, Bob 85. Yeah, just what we defined. And each time we go inside this dictionary, we get the student name in here. So right now, student is equal to Alice, as you can see. Then we define a grade, which is whatever the grade of Alice was, which is 80, as you can see here. In fact, let's just look here. Then we write that to the screen. We see Alice has a grade of 80. Then we take the next student, which is now Bob, and we say that the grade is 85, and so Bob has a grade of 85. And so on until we write for each of the students here. This is what a dictionary allows us. We can iterate over keys. So the terms, keys and values. These are the keys and these are the values. Keys are always strings and unique. Values can be anything and can repeat. Yeah. We can iterate over their keys like this. We can also iterate over values. Like, for example, if we care only about the grades, we could do it like this, doing grades.values. And in this case, we would only see the grades and nothing else. You can see here 80, 85, like this. So this would only give us a list of grades. Also, we could directly iterate over the entire key value pair like this. We could say for student, comma, grade in student grades dot items, and we can do like this. You notice this is actually doing the same job as this. In this case, we only got the student and we extracted the grade ourselves. But if we say dot items, we get a list of pairs. And the list of pairs is, yeah, basically just student grade, and so on. And so we see here, this gives us the same thing as what this gave us. That's right. Iterating over keys, iterating over values, and iterating over key value pairs. So these are the different ways we could use a dictionary. Now let's see what other use cases a dictionary has. We can check if a key exists, for example. Like if Alice is in student grades, we can say Alice is in a dictionary. But we know that some of keys are not going to be in a dictionary. So we know that Alice is in the dictionary. But what about, I don't know, Arnold? We know that Arnold is not in a dictionary. So let's just say else Arnold is not in a dictionary. And because Arnold is not in the student grades keys, we'll see that Arnold is not in a dictionary. So here we say if something, some element in student grades, and this will just check if one of the keys is equal to this value. And by the way, this also works for lists, if you remember. Like up here, for example, when you have senses, you can check if site in senses, let's just say site is one of the senses. And you can see here, site is one of the senses. It's printed because site is an element in this list. Right, so this is one thing we can do. Another thing we can do is to change value of an element of a key. Here's what that means. We know that the grade of Charlie is 25, but let's say he took a retake and now his grade improved. We can say student grades at Charlie is now equal to 50, for example. We can just print student grades to the screen to see what would happen. And we can see here Charlie's grade has changed. Another thing we can do is we can add a new grade, and here's how we could do that. Let's say a new key of someone who we don't have in our list yet, like Frank. We don't have a Frank yet. So let's say, yeah, his grade is, I don't know, 80. And let's print the student grades again. You can see here, Frank got added. Now, if we wanted to remove Frank from student grades, we could do it like this. Or let's say we want to remove Eva, for example. Yeah, why not? We say del, which stands for delete, and then student grades at that key. And you can see here we print it normally, then Frank is added, and then Eva is removed. So let's just mark them all. We can change the value of a key. We can add a new key value pair like that. We can remove a key value pair. And yeah, these are the operations that we can do basically. We can, yeah, change a value, add a new one, I mean new key with a new value, or remove a key which also removes its corresponding value. So these are the main different operations that a dictionary is capable of. So again, let's bring these back. So a dictionary allows us to iterate over the keys, just like this. It also allows us to iterate over just the values or the key value pairs and do whatever we want with them, just as we would in lists. It also allows us to check if some element is a part of a dictionary by checking if it's one of the keys. And it also allows us to change the value of a key, to add a new value with a new key, or to delete some specific key value pair. So with that, we basically already covered the contents of a list, of a tuple, and of a dictionary. I will send this file over in our Discord group, but aside from that, all the real intuition for when to use these, how to use these, when to use each and such, comes from solving real problems. In this case, I will try to make some realistic neuroscience problems, for homework. But yeah, generally practice makes perfect, so it's okay if some of these concepts don't click right away. After solving enough problems, you'll develop an intuitive understanding. And right now, this might seem abstract, like why are we bothering with lists and dictionaries and such, but when you see how they apply to real problems, like such as in neuroscience, for example, if we want to take all the measurements of our brain waves from last 10 seconds or something like that, we would have to use a lot of lists, a lot of tuples and dictionaries as well. And yeah, basically in week 6 we will see some practical applications of everything we've been learning so far, and it will click more. Until then, I will include some homework now, and I guess that's about it. If anyone has any questions, we can discuss them, and then we're done for today's lesson. Does anyone have any specific questions or misunderstandings or confusions, either about this or about homeworks that you'd like to discuss? Okay. Yeah, all right. Then I guess for now, this is it for today's lesson. I'll see you next week. And yeah, I'll upload the homework and I'll upload the samples that we've been going through. All right. See ya.